Hello, welcome back. So today we're going to talk more about rational functions, and we're going to be showing you how they're similar to rational numbers. So we're going to review what a rational number is real quick. So remember, a rational number is any number that can be written as a ratio or a quotient of two integers. So for example, two integers like say 2 and 3, if I want to write a ratio of those two numbers or a quotient of those two numbers, I would write 2 divided by 3. So 2/3 would be the rational number expressed here. So let's look at some other examples. So we had 2/3 was one example. Our integers or our whole numbers that we're using here are 2 and 3. Another example of a rational number would be something like -20 thirds, or -20/3. Okay, another example, we might do -4/5. Really, anything you can come up with where you have a ratio of two whole numbers. Okay, and by whole numbers, we mean numbers that aren't decimals or fractions. So yeah, we could keep going like this for a while. You can come up with lots of examples of rational numbers. One non-example real quick would be 7 divided by 0. Okay, the reason why that is not a rational number is because dividing by 0 is undefined. So you can't have the bottom of your fraction equal 0 or your number is going to be undefined. Okay, let's look at some other examples, add to our list here. Some that you might not think about. 3, for example. 3 is a rational number because we can write it as 3/1. It's still the same thing as 3. Okay, so just because it's not written as a ratio doesn't mean that it's not a rational number. A rational number means we can find a way to write it as a ratio. So another example might be 14. So 14 isn't a ratio right now, but I can write it as 14/1. So 14 is a rational number. Another example, 2.7. So 2.7 is a decimal. Okay, it isn't written as a ratio right here, but I can write that as 27 divided by 10, which equals 2.7. So this is a rational number because there's a ratio of two integers that it is equal to. So any number that you can write like this is going to be a rational number. Some other examples, 2/3. Okay, that's equal to 8, or 8/1, which is a rational number. So this is a rational number, even though it's not written as a ratio at the moment. 3 to the -3. Okay, that is equal to 1/27. So that is also a rational number. Okay, now you might start to think, well, isn't everything a rational number then? Can I always write something as a ratio? Well, not really. There's actually quite a few numbers that you can't write as a ratio. Some examples, square root of 5. Try as hard as you can, you will not find a ratio of two whole numbers that equals exactly the square root of 5. You can get close. Square roots of any numbers that aren't perfect squares are going to be what we call irrational numbers, numbers that can't be written as a ratio of two whole numbers. Another number you're familiar with is pi. Pi cannot be written as a ratio of two whole numbers. You can get close, but you'll never get the exact decimal of pi by using a fraction to represent it. So those are some irrational numbers. Another one, since we've been talking about logs lately, if you were to try and do log base 2 of 9 as a ratio of numbers, you're not going to be able to find numbers that will work for that. So these are all examples of what we call irrational numbers. They are not equal to ratios of integers. So with that definition under our belt, let's move on and talk about rational functions. So rational functions have a formal definition, and here it is. A function is called a rational function if and only if it can be written in the form f of x equals p of x over q of x, where p and q are polynomials in x, and q is not the zero polynomial. So that should sound a lot like the rational number definition, except instead of integers on the top and bottom, we're allowing for polynomials. So let's look at some examples. So I could do something like that right there is a rational function because it can be expressed as a ratio of two polynomials. Okay, another example might be something like x squared minus 4 divided by x minus 3 times x plus 1. Now this x minus 3 times x plus 1, that is a polynomial. You might be more familiar with it if we multiply it together. So we would do x times x and get x squared. We would do negative 3 times x and get negative 3x. We would do x times 1 and get 1x. And then negative 3 times 1 is negative 3. And now I can combine my like terms. The negative 3x and the 1x make negative 2x. So this is going to be x squared minus 2x minus 3. And so I could replace the bottom with this. It's the same thing. And there you go. There's another rational function. Whether you write it like that or whether you write it like we had it before, it is still a rational function. There you go. Sorry, my handwriting's a little bad. One non-example, real quick, would be something like x squared plus 3x plus 2 over 0. So in the definition, it said we can't have the 0 polynomial on the bottom because that would make this undefined. So just like you can't have a rational number with a 0 on the bottom, you can't have a rational function with a 0 polynomial on the bottom. Okay, so there's a good review of what rational numbers are and an intro to what rational functions are. What we're going to focus on today and next time is what are the similarities between these two groups. So with rational numbers, we can simplify them, we can multiply and divide them, and we can add and subtract them. Well, with rational functions, turns out we can do the same things. And not only can we do the same things, but the way we do it is very much the same as the way we do it with rational numbers. So back in junior high and elementary school, when you were simplifying these rational numbers and multiplying them and dividing them and adding them together and subtracting them, all those methods that we used back then are basically what we're going to use to do what we want to do with the rational functions this year. And if you forgot, don't worry, we're going to help you remember how to do all that stuff. Not only will you learn how to do all this stuff with rational functions, you also get to review how to do all this stuff with rational numbers.